I think that I can hit done. It'll be okay. Okay, while that's loading, we're gonna hop over here to here. Sign in. Allow. Thank you. Go away. Go. And calculus. That was the old one. That's correct. Let's see. Exam 1, exam 2, correct. Chapter 3 and chapter 4. How do I want to do it? I mean, I guess I could do that. Okay. Okay. So I was trying to decide. So we're going to do exam 2 review session. And so I was trying to decide if I wanted to jump between 3 and 4 today. But I think what I'll do is I'll focus on 3 today, and then we'll focus on 4 on Wednesday. Yeah, that'll be okay. That's fine. Okay, so let me pull this up. How many questions? It should be that is correct, Mundo. Let me see. Give me a random number. 97. Okay. Here. Okay. Zoom. Start streaming. Share my screen. Start the broadcast. And optimize the video. Okay. All right. So we'll start here. And let me log in here so I can see as well. Right there. Okay. All right, gentlemen. So we're essentially, quote unquote, in the home stretch, right? We have 6 sessions remaining. So exam 2 has been out since yesterday sometime. You have all of this week to work on it. Unlimited attempts, the system is set to take your highest score. I think it's due at the start of class on Monday. And then beyond that point, there's the late penalty, right? So we're rapidly approaching like the hard deadline for all assignments. So if you're not caught up, maybe I should like update your all's grades. That's a good idea. Usually I do that after the exam. So I'll try to make sure your grades are at least updated before our last session. I do want you to finish exam 2 before I do that, because that's a major part of your grade. So then you can expect grades to be updated sometime after Monday. I might even take Monday's class, maybe not, to update the grades. I'd rather not do that though. So sometime after Monday next week, I'll update grades, and just try to make sure that everybody has a plan of action. Oh man, this is about to die. This. Yeah, I don't ever think about like my keyboard until I sit down for class. Most times I remember to like at least put it on the charger. Let me charge this as well while I'm yapping. Let's charge. All right. Yeah, so we're rapidly approaching the end of the semester. So again, exam 2 is out right now. So we'll take some time today and on Wednesday to just review for it. So as you work on your exams, if you have questions, you can write down your questions and you can bring them up during class, and we can work on it together. Like it'll be okay. So exam 2 is this week. And then we'll try to update grades after it's due. So, you know, if it's due at the start of class next week, then sometime shortly thereafter, we'll update grades. So starting like from next Monday, I think we have 4 sessions at that point. And then so with the remaining 4 sessions, what we'll do is review in preparation for the final, and we'll pretty much take a chapter per day to review and try to, you know, and so these last ones low key kind of get a little like a double review because we're reviewing for exam 2. And then we go back and, you know, they'll pop back up in the near future. As usual, if you have questions, feel free to unmute yourself to get my attention or type in the chat or the Q&A. We can make sure to get it addressed. Also, I know, and I don't really think this applies to too many people here, but I know I sent an email a couple of weeks back, you know, with the excessive unexcused absences. So like just, it's a good idea to check Blackboard for your attendance. And if you see like 5 or 6 or more unexcused absences and you intend to finish, if you haven't done so already, you know, just send me an email and probably text me as well so I can know that you emailed me, so that we can make sure that you can, like, you're not being booted because of that, right? If you intend to finish, then we can not let attendance be the reason you don't finish, right? That's if you intend to finish. There are some guys that have been MIA that I don't think intend to finish. I think I emailed them, but I don't think I heard back from any of them. So I'm gonna try to do one more reach out, and then we'll see. I'm gonna just submit the names, and we'll go from there. But that's, for most of you guys, that's really none of your concern. Okay, so let's just kind of hop into and see what we can get into. So if we hop over to Pearson. All right, so for chapter 3, there's a study guide, and these are basically questions from the study guide. I think it's pretty much all questions that you can possibly come across in chapter 3 in this platform. And so it's really just for practice. You're not responsible for the study guide, so we're just going to use it for that. Let me see. It says an apple farm yields an average of 44 bushels of apples per tree when 18 trees are planted on an acre of ground. Each time one more tree is planted per acre, the yield decreases by 1 bushel as a result of crowding. How many trees should be planted on an acre in order to get the highest yield? It seems like a rate. Let me see. Is this like, let's see. So an apple farm yields an average of 44 bushels per tree when 18 trees are planted on an acre. Okay, so we got some like rate of change. Each time one more tree is planted per acre, the yield decreases by 1 more bushel per tree. How many trees? Okay, I think I'm going to use my viewing example because I'm just not visualizing it. So let me see, make a list of the variables, that's fine. Number of bushels versus number of trees, and is X the number of apples. Number of bushels decreases. Also, when there are 28 trees, the bushel of apples per tree is 50. Linear equations, okay. Number of bushels, say we have 50, number of trees is 28. So then every time we increase the number of trees per acre by 1, the number of bushels decreases by 1 in this context. So then when we're up by 2, we're down by 2 there. Okay. So X is the number of trees, let me see. Let X represent the increase in the number of trees. Okay, that's fine. Number of bushels per tree is this. Okay, that's fine. That's fine. Number of bushels per tree times the number of trees. That's the total yield. Okay. So we want to maximize this. Okay. Okay, I feel like this isn't too terribly bad with this context. Okay, I kind of want to take it from here, right? Based on the structure. So like I think this chart kind of breaks down most of it, right? So we have the number of bushels versus the number of trees, right? So in this one, it was 50 for every 28. Every time the number of trees in 1 acre increases by 1, the number of bushels decreases by 1, right? And so then they let X be the number of trees that we increase in an acre, right? So then we get these 2 linear. And then it says that the total yield is going to be the number of bushels per tree times the number of trees, right? So you multiply those 2 expressions. Then we want to maximize that guy. Notice that guy is what, a parabola, right? It's a downward facing parabola. The highest powers are 2, so it's a U-shaped curve. Leading coefficient is negative. So then we can maximize it, right? You know, if we were using college algebra, right, because of the parabola, we could use the vertex formula. It'll take us straight to the vertex. Since this is calculus, we could, you know, take the derivative, set it to zero, that kind of thing, right? Okay, so let's transfer this notion to ours. So what you just saw me use with the viewing example is the main reason why I vouch for like Pearson, right? If you get stuck or if anything isn't clear, then most of the questions, if you haven't realized it by now, have that little explanation on viewing example, right? So let me pull a copy of this and see if we can construct something similar. Yeah, for like whatever reason, I was just not organizing it mentally. I was like, I am not seeing it. So I was like, let me see the structure. I was like, okay, I think I got it now. Okay, so let's pull a copy here. Actually, no, it's not what I want. Right here. But I feel like the main, at least the main thing for me, was how to build it, and then we can take it from there. I was charging. I was like, I just had my pen. See, my brain is already. I'm telling you, every time I get closer to the term, everything just shuts up for me. Okay, so we had what, bushels versus trees. So let's say if we did a chart, like we said, bushels. Let me see, where is it? Yeah, bushel versus trees. Okay. 44 bushels per tree. So we're able to get 44 bushels when we have 18 trees planted, right? Every time one more tree is planted per acre, so like if we had 18 plus 1, the yield decreases by 1 bushel. So then we get 44 minus 1 bushels. All right. So then if we just for context, 18. So if we had 2 per acre, then we can expect 44 minus 2. So then the expressions are going to take on the form, if X is the number of additional trees that we plant per acre, then we would have 18 plus X, and then this is going to be 44 minus X, right? So then it says how many trees should be planted on an acre in order to get the highest yield. So we want to maximize the yield. So if we want to explore the yield based on the number of additional trees, number of bushels times the number of trees, right? So basically multiplying those two expressions at the end, 18 plus X times 44 minus X, okay? So then if we expand this guy, I don't know. Hey, Google, no, forget it, cancel. I'm gonna I already know I'm gonna need it. Let's go like this. Right here, right here. Okay, that looks good. I'm just gonna right there. Okay, right here. Come on. Okay. Come on. There you go. What time is it? Oh, also available. So you can do that at your leisure, all right? So I just want to encourage you all to submit those. 18 times 44. Oop. Okay. 792. Outer minus and inner 24, 26. So plus 26. And then minus x squared. All right. So if we expand it, we get something like this. So again, it's a parabola. Now from college algebra, we could use the vertex formula to find the coordinates of the vertex. You know, we got a U-shaped graph that's upside down. We could do that. In calculus, right, if we want to maximize this yield, right, so we want to find y max. I'm gonna just call it like y max. We want to maximize this guy. So that's going to occur at the vertex, right? So we can use like the first derivative test. All right. So let's look at y prime. Let's see. So it's going to be a negative 2x plus 26. So then if we set this to 0 and solve, subtract and divide, x equals what? 13. So we're saying that the max is going to occur, or our critical number is 13. So then, we should continue the first derivative test where we look on either side of 13 and see and observe the sign of the first derivative. For instance, a number to the left of 13, an easy number is like 0, right? Like, for instance, say this is our positive x over here. Here's 13. We're looking at the f prime. This is 0 in the first derivative. If we choose a number to the left of 13, again, 0 is an easy number to test, we get a positive result. So then that implies that the original function is increasing on the left side of when x is 13. If we choose a number on the right side of 13, something like 14, right? 14 times 2 is what, 28? Negative 28 plus 26 is going to be negative. So all the results over here are going to be negative. Right, so then that implies that we have a local max right here, right, when x is 13. Okay, how many trees? So according to this, it should be 13 trees, and then to find out what's the maximum yield, we plug that 13 into that part up there. 18 plus 13 times 44 minus 13. So the max yield we can anticipate is 961. Wait a minute. How many trees? Yeah, 960. Well, it should be planted on an acre. No, that's not right. Okay, well, that's the max yield. And then the total number of trees would be 18 plus 13, 28, 30, 31. So 31 trees, right? Yeah. Okay, let's see how if that works. So let's go over here. Right here. Get rid of that. In order to get the highest yield, this many trees should be planted on an acre. We got what, 31. So let's go 31, enter. That was an adventure, right? So I thought that was interesting because, at first glance, I was like, okay, I know it's something simple and I know I'm overcomplicating it, but I couldn't see the structure. And it was like some kind of table. And then when I glanced at it, I was like, oh, it wasn't that bad, right? The number of bushels versus the number of trees, and then we kind of went from there. And so again, but again, but that feature of view an example, that's the very reason why I vouch so heavily for Pearson. That's like the core of how this is the best one in my opinion. I've used so many other like online learning platforms, and none of them are as user friendly as this. None of them have as many like learning aids and resources. And the others they're always missing some key feature. If it's not a learning aid or the e-textbook. So anyway. Anywho, I mean, I'm sure you guys are well aware of like its features at this point, and hopefully it's been serving you. Let's go to question 36. Let's go to question 36. So by now, hopefully you can at least see like, okay, why I structure things the way that I do. And I mean, it's not 100% automated, but a lot of things are automated. Okay, let's take a look at this one. So it says, for the following function, give the coordinates of any critical points and classify each point as a relative max, relative min, or neither. Identify intervals where the function is increasing or decreasing. Give the coordinates of any points of inflection. Identify intervals where the function is concave up or concave down, and then sketch the graph. Okay. I'm going to try to take my notes here without writing anything, but I do need my first derivative and my second derivative. So I think what I'm going to do is go ahead and find my first derivative and second derivative. As a matter of fact, what I will do is make myself a little split screen. Now, I know on the left, matter of fact, let me at least pull a copy for your reference. Let me just pull a copy. Hope everyone is doing well. You had a good weekend, and you're doing what you need to do to get ready for your finals and to finish strong, right? There's no reason to not finish strong in my class, I mean, at least that's what I feel. Like I don't know what you guys experience. I know how it is as a student. It's just a lot. It can be a lot, and so I try to meet you halfway with the structure as best I can. Okay, so anyway, that's for reference. So again, we said we needed the first derivative and the second derivative to answer the question. So let's get a copy of the original. G of x we got this x cubed minus 9x squared plus 15x plus 3, right? So then our g prime, let's go ahead and take the derivative. What is that, 18x plus 15, okay? And then let's go ahead and find g double prime. Okay, that's what, 6x minus 18, okay? So let me, can I get rid of that? That'd be nice if I can get rid of that. I'm gonna change the view just a little bit. It's gonna be charging while I'm working. I'm pretty sure it's good though. Okay, so what are the coordinates of the extrema? Any critical points, and classify them as either relative max or relative min. Okay, so the relative max and min, we get that information from the first derivative. I guess we need to do some more work because those are going to occur when the first derivative is either 0 or undefined. So in this context, it's going to be where the first derivative is 0. Okay, so we need to find out what values of x make the first derivative 0 here. So we got this 3x squared minus 18x plus 15. We want to set it equal to 0. Now, off the rip, it looks like all the coefficients are multiple of 3. So I'm going to go ahead and factor out that 3. I'll write it like this. We got x squared minus 6x plus 5. All right. So then maybe we can get it to some form like this. They're the same, so both minus. What is it, 5 and 1? So then from there, the values of x that make this 0 are going to be what, 1 and 5. Okay. So our critical values are, our critical numbers are when x is 1 and 5. So say this is our positive x. Say here's our 1, here's our 5. If we look at it in the context of the first derivative, these are going to give us zeros in the first derivative. Let me give myself just a little bit of space here. That's better. Okay. So then again, so what these do, these break the number line up into, like, in this case, 3 different regions or whatever, 3 different sections. So, you know, you have like this. I really don't want to use this shape, but you know, I think it'll help with the context. All right, so those 2 critical numbers break the number line up into like 3 different regions. We got this region A, right, which is basically all the numbers to the left of 1. There's region B, which are all the numbers between 1 and 5, and region C, all the numbers to the right of 5. Okay. So then if we choose a number from region A and test it in the first derivative, something like what, 0? Double negative is positive. All right, so when we plug 0 into the first derivative, it looks like we get a positive result. Here, let's go like this. Again, we got a positive result here. So that implies that all the values in this region are positive. So the function should be increasing on the left side of 1. So then next, in region B, we're going to choose a value, maybe something like 3. If we plug 3 into the first derivative, the first factor is what? Negative, and then positive. So a negative times a positive is going to be negative. So then all the values in here, when we plug them into the first derivative, should behave this in a similar fashion. It should all be negative, which implies that the original function is decreasing. And then to the right of 5, something like what, 6, right? Positive, positive, right? Into the first derivative, right? So it looks like, so based on this implies that this is what, a local max, and this is what, a local min. Okay? At those values of x. Let me see. Simplify your answers. Use integers or fractions for any number in expression. Type in ordered pair, right? So we have our x value. We need to find the corresponding y for each of these x's. Let me use this guy. What I'm I'm going to do is go to my y equals, clear all this out. We got what? 3x squared minus 18x plus 15. Okay. And then I'm going to go back to my home screen and I want to evaluate this. Well, we just want 1 and 5. I'm going to just do this. I just like this. I want to evaluate this when x is a 1. We get 0. You know what? That was the first derivative. I did the wrong thing. All right. I think we're still live streaming, so let me go ahead and share my screen. Sorry about that. Somehow we got disconnected. Let me see something real quick. I think we look good. You guys look good, man. Okay. Get rid of this. Go. I don't know how to get rid of it. There it is. Okay. So let me share my screen. Start the broadcast. Optimize. We're gonna hop back. So we were here. Yep. So again, for my first derivative test, let me join. Let's go. Don't connect and join. Stay as a participant. Okay. Hopefully it doesn't stay blurry like that. Oh no. See, I can't do anything about that. I don't even know why it does that. Probably some bandwidth or something. I mean, we have like the fastest that's offered, like fiber optic. I don't know how to. You probably need a newer device. Anywho, yeah, that's why I'm trying to expand things and I try to talk through it. So it says on what intervals is it increasing or decreasing? Again, from our first derivative test, we can say it's increasing in regions A and C. So we just need to get those intervals. and it's decreasing in region B. Let me see. So it can't be B, C, or D. So it should be A. It's increasing. Okay. We got two separate intervals that we need to capture. Come on. Okay. Let's do parentheses. Negative infinity up to what? 1. Okay. I need a comma, parentheses, and then from 5 to infinity and beyond. Okay. Function is increasing, basically outside of 1 and 5. Usually, for the discussions of increasing, decreasing, and constant, it's always parentheses. That's the impression that I have. The function is decreasing between 1 and 5. All right. So, come on. Parentheses between 1 and 5. Yeah. Okay, let's check. Okay. What are the coordinates of the points of inflection, right? So the inflection point or points that we get that information from the second derivative, and those occur where the second derivative is either 0 or undefined, right? So let's kind of give ourselves a little bit of space here. Second derivative, we got what? 6x minus 18. All right. Again, we got g double prime 6x minus 18. Okay. So then if we set this to 0 and solve, what is that, a 3? We should so to complete the test for points of inflection, let me just do it instead of trying to I'm always like, the word lazy is like, it's so contextual, right? Because in one context I'm being lazy, in another context I'm being efficient, right? It's all in how you spin it, you know what I mean? Anyway, let me not do that and just go ahead and finish it. So like if our critical value is 3, and again we're comparing this to the second derivative, I know I heard something, I think it was unintentional. I think you guys are okay. Let me check participants. I think you guys are good. You good? Going once, going twice. I think it's good. All right. Here. Okay. So again, so similar to the first derivative test. Did you crash? Okay. Similar to the first derivative test, you know, we can kind of copy like this guy. Copy, paste. Let me give myself a little bit of space. Okay. All right. So that critical value breaks the number line up into 2 regions. So number to the left of 3 to test, the easy number would be 0. If we plug 0 into the second derivative, we get what, a negative result? So this implies that the original function is what? Concave down to the left of 3. We choose a number to the right of 3, something like 4. 24 minus 18 is a positive number, right? So that implies the original function is concave up, which means that this is an inflection point when x is 3. And so we need to find the corresponding y. So then I'm just going to recall and change it from 5 to 3. Corresponding y is negative 6. So then we're saying that the point of inflection occurs at 3, I think it was a negative 6. 3, negative 6. Okay. And this was again a point of inflection. That's fine. Let me just highlight it. Okay. All right. So let's submit that. Okay, we did that. What are the coordinates? So we got A, 3, -6, 3, -6. Okay. On what intervals is the original function concave up or concave down? Let me see. Functions concave down. Never, never. So it can't be A or C, right? Because we have, from our notes, we have that it was at one point concave down, then it went to concave up. So it should be B. It was concave up on the right side of 3 in that region B. So that's from 3 to infinity. Okay, parentheses, 3 to infinity. It was concave up. And then concave down from negative infinity to 3. So negative infinity up to 3. Okay. Check. Okay. Was that it? No? Okay. So for my original, right? So I'm gonna pull a little bit of college algebra. Let me see. We had our max and our min, right? Let me see. We had our local max at 1, 10. Okay. So that means it could either be A or D. And then we had our local min at 5, -22. They both look similar. Okay, let's see if we can find some other distinguishing feature. Is that? And then we had a point of inflection at 3, -6. 1, 2, 3. How much is that? If that's 30, 1, 2, 3, 4, 5, 6. So that's 5. That's pretty close. Okay, does 1 pass through the origin? What was that? 110? Is that 10? If that's 15, 1, 2, 3. Okay, I think that D, the max, I don't think that's 110. Can I? Right, because if that's 15, 5, 10, 15, so each tick mark is 5, that max needs to be higher, right? 5, 10, 15, 20, 25, 30, 35, right? So that was what, 5, -22, 5, 10, 15, 20, 25, and that's the wrong min as well. So it shouldn't be D, it should be A. Okay. So a little bit of an adventure, but it was a good opportunity to review. Okay. So let's get rid of that. We completed that one, so let's do another one. Let's generate. Let's go 118. Let's see what 118 is talking about. What you talking about, Willis? Come on, all the way, not all the way. Right here. All right, so this question comes from 3.6, question 35. I think that's business economics. Assume that C of X is in dollars and X is the number of units produced. And so for the total cost function, we have this. Find our delta C and C prime when X is 70 and delta X is 1. The change in C. X is 70. So I'm thinking that for C prime, I mean delta C, you basically, let me think. It's like the change, right? So y2 minus y1. So you can say it's like C of 71 minus C of 70. Yeah. So let's try that first. I don't want to look this one up. So like we're gonna let X be 71, we get a result. Let X be 70, we get a result, and then so say the larger the former minus the latter, right? Okay, let's see if that works. I think that should work. Because the delta C just means the change in C. So I'm just taking a literal y2 minus y1, right? Okay, and I know it's a little bit small. I can zoom in some right here. Okay, and right there. Okay, so what I'm going to do is go to my y equals, and I'm going to type in that function 0.01 x squared plus 0.5 x plus 30. Okay. Then I'm going to evaluate this. Matter of fact, I'm going to just do it in one go. So I'm going to call on that function. I want to evaluate this function when x is 71. Then I'm going to say minus evaluate that function when x is 70. All right. So we're essentially doing y2 minus y1. Okay. $1.91. Type an integer or decimal around the two decimal places. Let's put one. We got $1.91. Okay. Okay. C prime, okay, when x is 70. So what's that? That's the marginal cost where once we've produced and sold 70, or we've produced and sold 70 items, the cost to produce an additional item, right? Okay, I think that's essentially what the marginal cost is. Anyway, so we need our C prime. Okay, so I'm going to use the calculator. Let's see if I go with math, derivative, right? Number 8. So I want to take the derivative of this function with regards to x when x is 70. I think that's it. Because basically you take the derivative evaluated when x is 70. That's what this little expression should be doing. And we should get something close to 1.91. Okay, and we did. All right, so 1.9. That's not what I typed. 1.9. There we go, that's better. Okay. So this is just trying to make a distinction between the literal difference between like the cost of produce and sell 70 items versus 71 versus the marginal cost of like once we've produced and sold 70 items, the cost to produce one more item, right? Oftentimes the marginal cost, which is the C prime, is close to the literal difference, which is the delta C. Okay, we can hang out for like 10 more minutes, all right? I think we get out at 7:15. Let's generate. Let's go to question 97. 97. Yeah. Oh, we didn't. Why is it giving us 97? We'll do 98. That's fine. Okay, let's give this one a go. So it says a car rental agency rents 480 cars per day at a rate of $40 a day. For each $1 increase in rate, 10 fewer cars are rented. At what rate should the cars be rented to produce the maximum income? What is the maximum income? I feel like this one is similar to the first one that we did, so I'm tempted to build a similar table. Let's kind of start there and see if we can get that to work. Let me get a copy. Let me see. Let me try and see if I can get it before I look. Okay, we're gonna hop over here. There you go. Right here. All right, so let's see. Car rental agency rents 480 cars per day. This many per day for each income, right? So number of rentals versus the cost, right? Because I'm trying to build a similar table, right? So if we said the number of rentals versus the cost to rent it. Okay. 480 cars per day. So one day we did 480 cars at a rate of $40 per day. All right. For each $1 increase in the rate, so then we can call this the rate. I mean, the cost is fine. So every time we increase this by $1, 10 fewer cars are rented. So it's going to be 480 minus 10. All right, if we just did it once more, if we increased it by $2, then that's going to be 480 minus 20, right? So it looks like this is going to be what, 40 plus X, right? This is going to be 480 minus 10X, okay? Where X is the number of dollars we increase the rental, right? The number of dollars we increase the rental by day. Each $1 increase in rental cost per day. Okay. We want to find a maximum income. I'll just call it I of X, I guess. Probably needs something better than I, but I'm gonna just call it Y. We want to maximize this. All right. So revenue, let's call it revenue. So it could be money generated, right? We basically multiply those expressions, right? Number of rentals times the cost of each rental per day. So then it should be 480 minus 10X times the 40 plus X. We'll expand it, and then we want to maximize the revenue based on this scenario, right? So we want to find the max revenue. 480 times 40, 1920, 19200. So 84, let me see, 480 minus 400 is going to be plus 80x minus 10x squared, right? If we FOIL it out, again, we want to maximize this guy. So then let's look at R prime. We take the derivative, we get a negative in a time. Okay, this is probably the last one. Negative 20x plus 80. If we set it to 0 and solve, subtract and divide, what is that, a 4? Negative 80, right? So basically we're saying increase the cost by $4 to maximize the revenue, right? Okay, so I think we have everything that we need. Let's go ahead and wrap this up. Full screen. And then you, come on, go here. You can do it. Okay, let me zoom out some. That's part of what's throwing it off. We might have time for that. Okay, so it says the rental agency will earn a maximum income of this when it charges this, right? So the max income, right? So minus 40, so 440 times 44, and that'll give us the max income. Or do we have it here? No. Actually, I do feel inclined to put it here. Yeah. So what is it? 480 minus 10x 40 plus x. And then we want to evaluate this when x is 4. $19,360. When it charges $44 per day. Okay, let me see. Moment of truth. Woohoo! Right? Especially with it being right next to the previous question. I mean, it's not always guaranteed to be like that. But I was like, okay, well, it was given the vibes that it was a similar structure, just a different context, and it was. That was interesting. Okay, let's keep going. Yeah, let's go to at least 710. So we got time for at least one more. Just depends on which one. Generate. Let's go to question 82. Question 82. This will probably be the last one for the day. Find the absolute max and min values of the function over the indicated interval and indicate the x values at which they occur. So for absolute max and min, it's the same procedure as the local max and min. It's just that you also test the endpoints in addition to any critical values that you find. So let me get a copy of this guy. Okay. Let's hop over here. Come on, where are you? Oh, thank you. Lisa. Dang. Sheesh. Oh man, it sounds like people are stressed out. That's crazy. Sorry, guys. Anywho. Okay, so if we want max and min, we need to look at the first derivative. I do not feel like doing the first derivative of this, but we're gonna go ahead and knock it out. So looks like we're gonna use the quotient rule, right? So f prime. The bottom, which is this guy. The derivative at the top is this guy. So low d high minus high d low, which is what? Just 2x over the bottom square. Let me kind of see if anything we can get this to simplify down at all. 3x squared plus 27 minus 6x squared negative 3 okay. We could factor out the negative 3. We would have what? X squared minus 9. I don't think anything cancels, right? Because that's going to be x minus 9 times x plus 9. Or x minus 3 times x plus 3, right? But nonetheless, nothing cancels or simplifies. So then the critical values are going to occur when this is either 0 or undefined. I don't think we're going to have any x that makes the denominator 0, so it won't be undefined, right? Because if you just focus on, if you take that expression in the denominator, it's a parabola that we moved up by 9. So there's no value of x that's going to cause it to hit the x-axis, right? So the no value of x is going to make the denominator 0. So then now we're just limited to what values of x that make the numerator 0. Again, this is f prime of x. So if we set the numerator to 0 and solve, subtract and divide 9. So then plus or minus 3. And we can, those are candidates. We need to finish the test. So say this is our positive x in this direction. And we want to consider -3 and +3. Look at our first derivative. So for instance, if we plug -4 into the first derivative, again, you have like your, this is region A, region B, region C. When x is -4, let me think. So these guys, this is a 0, that's a 0. So if we choose a point in region A, plug it into the first derivative, let me think. 16 times 3 is 30. So that's ultimately going to be a negative up there. A negative divided by a positive is negative. So we got that the first derivative was negative in this region, which implies the original function is decreasing. Between -3 and 3 is something like 0. That's going to be positive, positive. I'm getting a positive result here, right? And then something to the right of 3 would be like 4. And I think it's a repeat, right? We get a similar thing going on as region A. So it looks like it's negative, right? So then we have a minimum, local min here, local max here, and then we need to also compare the endpoints, right? So the endpoints I think are plus or minus 4. So then we'll say extrema versus our critical value, right? So we got what, -4, -3, 3, and 4. Those are the numbers we need to test in the original. Okay. Copy of the original is there. I'm going to go to my y equals. Let's do 3x divided by x squared plus 9. Okay. Okay, that looks decent. So then I want to evaluate this when x is -4. We get a y value of -0.48. I want to evaluate this when x is a -3. We get a -0.5. I want to evaluate this when x is +3. We get a 0.5. And evaluate this when x is 4. 0.48. Okay. So the max, it looks like it's the endpoints. Right? Nope, not the endpoints. Our critical values. Those based on this interval. We got a max value here. And we got a minimum value here. Okay, I think that might be okay actually. Okay, let's see if that works. Again, hopefully it does, as we're trying to get out of here. So the max value. Okay. Zoom out so I can see better. Let's see. Max value we got was 0.5, 2 decimal places. So we got 0.5 when x is 3. Man, I hope this is right. So if it's not, I got to go back and figure out what we did wrong. Check. Okay, that's good. And the min we got a minimum value of -0.5 when x was -3. Okay, check. Okay. Well, that is enough for one day. Are there any burning questions before we go our separate ways? So I'll make a copy of this available and I'll attend it shortly. So again, just to recap, exam 2 is available now. It's a good idea to go ahead and work on it. However you've been doing it. And then if you have questions, you can bring your questions to class on Wednesday. We can talk about it. If there aren't questions, then we will on Wednesday we'll focus on chapter 4, which is the other half, because today was on chapter 3, and just kind of doing as many questions from chapter 3 as we can, and then we'll do something similar on Wednesday with chapter 4. And then next week, each day we'll pick. Monday is chapter 1, Wednesday is chapter 2. The following week, Monday is chapter 3, Wednesday is chapter 4, and then that chapter 4 session, that's going to be our last in-person session. It'll become available that Sunday as we approach the week of finals. You can access, how the spiel goes. And again, I'll try to have your grades updated after exam 2 is due, so sometime after next Monday. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great week, evening, gentlemen. We're still going to meet on Wednesday, and take care. I was this close. I wanted to say have a great weekend. I told you my mind is already in summer mode. I am not here. All right, guys, take care. See you next time.